Wonderful. I think that's us. Everyone, welcome. Thank you for coming to watch me today. I know like everyone's really excited for the party, and we all want to get there and get away and get drunk. But I'm going to talk to you today about the absolute beginner's guide to test-driven development. First of all, I want to say thank you to Code.talks for having me back. I was last here in 2019, which I think was the last Code.talks there was. I've been waiting 3 years to get back. And the reason I've been waiting 3 years to get back is, one, this is probably one of my favorite conferences I've ever been to and spoken at. And the other reason I've been waiting 3 years to get back is I've still got drinks tokens for the party. But I don't know many people here today, so if you want to come and get some drink tokens, let's make friends, and I'll give you some drinks if you run out of your own. So this is actually version 2 of this talk that I'm giving. The reason it's version 2 is, so I'm going to give you some work today because I'm moving back and forth. The reason it's version 2 is because I gave the first version of this at a conference in Scotland recently, and I wasn't really happy with the way it went. I felt like I tried to do too much, and it was kind of confusing. So I've stripped this down to basics. We're going to really just get the basics right, and then you can go home and learn it all yourself. So let's get to know each other a little bit. If I move over here, I can just about see you. So put your hand up if you already write tests, but you don't write them first. That's a good portion, probably about 40-50% of you. Who's tried TDD before but given up? Yeah, okay. Probably the same people putting their hands up for writing tests but not TDD. Who's never written a test? Okay, 1 or 2, yeah, don't be shy. And who's afraid of testing? I was really afraid of testing before I started. Okay, yeah, we've got 1 or 2 afraid of testing, fine. Listen, hopefully everyone's going to get something from today. I really hope so. So FAQs about TDD, the misconceptions maybe that people have when they start testing and TDD itself. One is, isn't it too time consuming? Will the business let me spend time on writing tests instead of delivering what they think is value? And of course, what you should be saying to the business is, the tests are part of the production code. The tests are what asserts that your behavior is as specified by the business. How do I write the test before I know what the implementation will be? Who's ever thought that? Yeah, a few people. Cool, right, well, we'll go through that in a moment. Who's ever wondered, do I need to write all the tests before I can write any code? No, I didn't see any hands there. Okay, I used to think that. Code coverage, that's a big one that people often wonder about. And the thing with TDD is that if you practice it as you're developing, you will just by naturally achieve 100% coverage. But coverage, I think, is the wrong metric. What you should have is confidence in your tests rather than coverage. Coverage can give you a kind of insight to where your testing is a bit light, but it's confidence you should be aiming for. And things like, when do I write a new test? When should I modify a test? We'll go into that in a moment. And do I always need to use TDD? Well, personally, I don't. I probably TDD about 80% of the time. If I'm writing some throwaway code, I probably won't even bother writing any tests. But if there's anything important, if the code is important and it's going to go into prod, I will TDD it. First of all, I need to be over here for this. Buy this book. This book is Test-Driven Development by Kent Beck, and I believe it's the original resource on TDD. I have the attention span of a goldfish, and I managed to read this chapter by chapter, and I thought it was really great. Let's hold it up so the people at the back can get a photo of it. Actually, that's a bit easier, isn't it? This book, Test-Driven Development by Kent Beck. Buy that book. I'm not going to teach you anything today that isn't in that book, but what I'm going to do is give you a springboard so you can take it and go, oh yeah, that fella on stage in Hamburg, he was talking about this. Who's heard of the testing triangle? If I move back over here so I can see you. Has anyone heard of the testing triangle? Yeah, a couple of people. So it kind of looks like this. This is my opinion of a good testing triangle. We've got unit tests at the bottom, which test behavior. integration tests, testing interoperability, and important user journeys at the top. Normally, I'd kind of jump and do stuff on the screen, but it's a bit too high for me there. We're going to focus on the unit stuff today, because it's the most important thing. And you can see it's at the bottom of the triangle. You should have more. The triangle is nothing to do with the ratio of how many types of tests you should have, but it's just a kind of visualization, right? You should have more unit tests than integration tests, and you should have more integration tests than end-to-end tests. Now, integration tests, they do things like that's at your framework level. So it's like, if I do something, does the database get updated? That's beyond the scope of what we're going to do today. And then end-to-end tests are you're really kind of like driving the browser and these kinds of things. All of your behavior should be in unit tests. So the way that the testing triangle doesn't work, first of all. And I thought this for a long time. I thought I need to write all my unit tests. And once I've written all of my unit tests, I need to write my integration tests. And once I've done all of them, I need to do my end-to-end tests. That's not how it works. And the way it actually works is you write some unit tests, you write some integration tests, to make sure that that you're persisting to the database or whatever correctly, and maybe you'll pop some end-to-end tests on top. Then you'll go ahead and add some more unit tests and some more integration tests. And then you might write a few more unit tests and integration tests, and then finally finish up your end-to-end test suite. And of course, this works for features as well. So feature 1 would have its own set of unit, integration, and end-to-end tests. Same as feature 2, and then feature 3. And globally across your application, you'll find that you'll get this kind of triangle again, this kind of pyramid. And why getting it right is important. If you don't get it right, it becomes very painful. Is anyone, so the people that are not testing first, or anybody that is testing, do you find testing difficult? Put your hand up if testing's a little bit difficult or a pain to maintain, and like you change a class implementation and tests start breaking and things like that. Does anyone have a few people? Yeah. So getting it right is important because, as I say, this is the ideal triangle. And what often happens is people test implementation details at the unit level. And then they pump the behavior up to the unit. And they say, well, I've got this class and it's got some dependencies and I'm going to get them from the framework or from the container or whatever. And so they start just testing the behavior at that level. And then they think, well, what's the point in unit tests if I've got everything covered here and I've got the confidence in the integration level? And then what happens then is the interoperability gets pumped up to the end-to-end level. And you start writing fewer and fewer unit tests because the unit tests are hard to maintain. Because each time you change a class implementation, something breaks. So you write fewer of them, and you put everything in the integration level, and you end up with the pirate ship. And then eventually, that becomes hard. And you put more and more tests then at the end-to-end level. So you end up with the inverse triangle or the ice cream cone. Does that look like an ice cream cone to anyone? Hands up if you think it's an ice cream cone. 1 or 2. I'll scale it down now. Anyone think it looks like an ice cream cone? What about now? So let's see some TDD in action. Oh, we're just about on time. Normally I run over on these kinds of things. We'll do some TDD together, right? So I'm using PHP for my examples, but this is applicable to any language. All right. The book itself, I think most of the examples are in Python. I think there's a bit of Java in there as well. But you can read the book. You don't need to understand the code. You need to understand what's happening. So let's say, for example, we're going to work on a feature in here, and we'll say it's a shopping cart feature. It's kind of simple, right? So if I just create a new directory, and what I'm going to do is I'm going to name my. This is bad. I can't type when anyone's watching me, and with a room full of people watching me, it's a little bit more nervy. Okay, so I'm going to organize my tests by feature for starters, because then if a test ever breaks, you know exactly what feature it will be affecting. So, and I'm going to put in here. So I'm going to call this shopping cart test, and this is going to be in tests, shopping cart. If there are any kind of PSR4 gurus in here. Please tell me why PHP Storm keeps knackering up that path. OK, cool. So I think we're good, right? So this is my shopping cart test. And this extends. I'm only using PHP units, by the way. In fact, I can just do test case. Great. And the first thing I can do, right, so this now, PHP Storm, and any IntelliJ product, I guess, will have this feature. I can just start running this. And it's going to ask me for the, this is running with Docker. As long as Docker is running, are we good? Lovely. OK, right. So I've got this output on the right-hand side. I'm going to talk about this. The very first thing I always do is toggle auto test. And what that does is just make sure it keeps running tests as I'm programming. And the other thing that I do is always just make sure that the auto test delay is on 1 second. OK, so you can see here, right, it says, there's no tests found in this class. Well, that's great. So I'm going to start thinking about a feature now for a shopping cart. And what we have to do is start at the simplest behavior and build it up from there. So the simplest behavior for a shopping cart would be a cart that's got no products in it. So we can create a test for that. OK, so public function test a new shopping cart is empty. And what I'm doing here, I'm describing the behavior that I expect in the test name. So you'll notice this as we go through, right? The test behavior is written in the name. So the expected behavior is written in the test name. And then the implementation of that test, the expectation is the actual details of it are in the method body. So I'm going to say cart equals new shopping cart. And then I'm going to say this. Assert, I can use either assert empty or assert same. This is kind of similar thing, right? I'm just going to say I want an empty array when I call get products on the cart. Okay, and you can see what's happening. I'm writing the tests before I even know what the implementation is going to look like. And because by defining the behavior that I want from the outside of the system that I'm building, I can go ahead and write tests without even having a clue what the actual implementation will look like. But we can see here now, right? So we've got this this red bit on the bit that says test failed, blah 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 blah, and it says shopping cart not found. Okay, so cool. We can go and create a shopping cart class. And I'm going to put that in the shopping cart namespace as well. Good. And then if I come back to the test, let's get that out of the way. I'm just going to import that. So the test reruns. And now it's going to say blah, 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 blah. No method, get products. So again, you can see that I'm defining how I want this class to work before I even know what the implementation of it is going to be. So I'm going to say get products. OK, I'm just going to add this method. And I know that this needs to send back an array. Now, the point of TDD is to make that test pass as quickly as possible. And the way that I can make that test pass as quickly as possible is I can just return an empty array. Bang, look, that test passes. Great, we've TDD'd, right? But you might be thinking, well, that's useless. Why do I want a cart that's always empty? The beauty of this, right, is now that I can go test a product can be added. OK, cool. Who saw that coming? So I'm going to say product is a new product. And again, this class doesn't exist yet. We're going to define it as we go. And then I'm going to say, right, so I want cart. I'm going to call something called add product on the cart. Again, this method doesn't exist yet. I haven't written it. And that's going to take the product. And then I guess when I call get products, I want to make sure that I get an array with that product back in it. OK, so now again, so we're on this red phase, right? So we need to make this red phase go to green as quickly as we can. So shopping cart product not found, so I can do product, and then I should be able to create class. Great. Yeah, that all looks good. Come back to the test, and good. In fact, I need to make that just run quickly there. Right. Undefined method, add product on the cart. Great. So let's go ahead and make this, and that's going to just be a void method. Now, there is no way that I can make those two tests pass without writing the correct implementation, because I can't make that empty array thing work at the same time as making it returning a product work. So now I have to create the actual code that makes this thing work. So I'm going to put a private array of products in here. Equals this. And then when we put a new product in, we're going to put this products equals product, right? Okay. So this is a very naive implementation. And then here I just need to return this. Products. Wonderful. And then on the right-hand side, when it runs, look, we've got two passing tests. And we've got 100% code coverage because we haven't written a line of code without having a test for it. So we've got confidence that both of those behaviors work. And if we go back to here, look, we've got quite clearly defined what the behaviors are. A new shopping cart is empty, and we can add a product. And then the implementation of it is in here. What about, say, let's add a new behavior. Let's say, for example, there was some sort of business rule that we can't add, for some reason, two of the same product. We can add different products, but we can't add two of the same product for some reason. Again, so we can just go public function test multiple of same product is not allowed. Okay, so this time I'm going to copy and paste this. And then I want to do expect exception. So can I add multiple? Let's call that exception. Who thought that they were going to come and watch someone make a load of typos today? Okay, and I want that exception to be thrown when I call add product a second time with the same product. A lot of people in tests pump this up to the top of the test. They say, well, at some point in this test, this exception is going to get thrown. Does anybody do that? Put the exception. Stop doing it. Because you don't know at what point in here that exception is being thrown. You want to make sure that that exception only gets thrown when you call add product the second time. So, right, I'm going to add this exception class. So if I do that, I can create this class. Yeah, cool, good. And we're just going to extend exception here. Not that one. This one, good. And then I should be able to import, that's already imported, good. Okay, great. So we've got this failing test, right? And it says cannot add multiple of the same exception is not thrown. Great. So now we need to go and add this implementation. So I can't do that really without having the real implementation of it now. Now that we've got this products array. So let's just do, say, for each this products. In fact, hold on. No, what I'm going to do first is the dirty implementation that we talked about, and I'm just going to say if this products is greater than 1. If I've got more than one product in here, I'm going to throw, yeah, we'll get it there. We'll get there eventually. Throw new, cannot add multiple exception. There'll be an empty message there. Okay, great. So, ooh, why did you fail? Right, okay, if this counts, blah, 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 blah. Okay, I didn't expect you to fail this time. At me shopping, maybe I've got the wrong namespace in here. Where are we? All right, who thought, I don't think we'd be debugging today. So I've got, so I'm counting, let's just var dump, count this products. Of course, it's because it's greater than 0. Right, I've already got one in there. Here we go, right. Yes, I've already got one in there. If it's less than 0, then we are going to throw, right? Because we've got one in there. Cool, we've got that behavior. Let's go back to our test. But of course, this is stupid, right? Because if I add any other product now, it's going to fail. So I need to be able to differentiate between products that we're adding. So let's say, for example, then product takes in its constructor some sort of name. So we're going to go public string PHP 8 for the when name, and then we're going to call that's going to be a read-only string. Okay, right, so now we've got here, right, so this is going to take a name. So let's just say we're selling LCD TVs. But what's happened is I've broken all of my other tests here because, look, it's saying I want this in my constructor. So it's broken all of my other tests. But this is okay because we've changed the interface for that product class. So we need to go ahead and just update these tests. So bang. That's fine. Good. We're all good. We're all good. So multiple of the same product is not allowed. But let's say that test multiple of different products is allowed. So now we need to change the implementation to allow for that behavior. In fact, I don't want an exception here. I want, say, product 1 is going to be an LCD TV, and this is going to be like a Game Boy or something. Can you still get Game Boys? Am I just showing how old I am? And that's going to be product 2. And then I want to do assert that we get, when we call get products, we want to assert that we get that array of product 1 and product 2 back, right? When we call get products on the cart, get products. So this is going to fail, and the reason it fails is because we're getting that exception back. So now I need to no, that's the wrong class. I need to do the implementation of this, and I'm going to say, right, for each this products as existing, if product name equals existing name, that's we're going to throw our exception here. Great, so we're green again. So we've gone from red to green, but now we can do some refactoring. And the great thing about this is we can do refactoring without breaking any of these tests. And this is the whole point of TDD, is that you can refactor to your heart's content. And as long as the behavior stays the same from the system that you're building, then the test will still pass. So let's say, for example, right, I want this check, if the product equals another product, I think that should be a behavior on the product class. I don't think it should be a behavior on the cart. It knows too much about the product's internals here. So I will add a new class. This is going to be called product test. And this is going to extend test case again. Okay, so let's get that running. Let's edit, right. Need to do this bit. Let's get that bit out of the way. And again, auto test. So I want to know if a product equals another product. So, and this is what we would call, say, like a micro test. Is anyone familiar with like the term value object? If you all put your hand up, I can just say, okay, value objects are really simple objects. They just hold some sort of value. So like the product class, right? That just holds a name. So this is a value object. And product value objects generally have just a little bit of behavior, not a huge amount. So function test equality. We don't need to make too many tests on this. So this is going to be test equality. And let's say, right, so product equals new product. And that's going to be just AAA, and we're going to say assert true product equals, we're going to define a new method, and let's go new product, again, AAA. Okay, so we're going to see like this test is obviously failing, so it's going to go, I don't know anything about this method you're trying to call. So we can go ahead and we can just add that method, and this is a Boolean, it returns, we'll call that other. Okay, and we can just go return true. Again, I just want to get that test passing as quickly as I can, because what I'm going to do now is add the other case where it's inequality, and we're going to say, right, this is just going to be B, and I want that to be false, right? Makes sense for everybody? I'll take that as a yes, good. So, again, now there's no way that I can make that second test pass without writing the actual implementation. So I can go return this name equals other name, and this passes. Great. So if I run all of these tests together, again, set the interpreter, good. Let's run that. We can now go ahead and refactor this second part here, this shopping cart here. So we can say if product equals existing, those tests, we're not auto-testing anymore, bang, okay. These tests are all still going to pass because we've defined the behavior and we're testing on the behavior and not on any of the implementation details there. So that's the demo there. There's more that we could go into. Maybe come and talk to me at the party or find me tomorrow or something. We can go into a whole load more stuff. I think, yeah, we'll go into more depth at the party. There might be a bit of time if during the question part for me to show some more examples. There are things that go wrong, right? So, these are kind of smells for if you're getting things wrong. So testing value objects in isolation. With that product class that I just showed you here, so if we have, let's say, the product test, I've seen things like people go in, test can be constructed, right? Whatever, like, imagine that says constructed, right? And what people then do is go product equals, imagine that says product as well. I'm trying to go quick for you lot. And we have this, and then they go, oh, this assert same product name is equal to this, right? That's stupid, right? Because all you're doing is testing a getter on a value object. That's not behavior. That is a brittle test. Because if you were to change, okay, so this is all passing at the moment. If you were to change this name value and this name value and that name value, look, the only test that's failed here is this brittle test where we're testing an implementation detail. If I get rid of that test, we've changed the internals of that class, but because we tested the behavior, it all still passes. All right? So so testing value objects in isolation, it's kind of a smell that you're getting things wrong, and it usually ends up in a one-to-one test to production code mapping as well, because you think, oh, there's a class, it has to have its own test. It doesn't. Test things that make sense to be tested together. If you've got a command class, don't test that on its own. Test it with the handler. A command is irrelevant without a handler, and a handler is useless without a command class. So test the things together. Data providers, I see quite a lot. So there's two massive misuses of data providers. One of them is, who does this one? Who knows what a data provider is, by the way? A couple of people. So data provider is basically a function that your test calls each time, and it gives it a different set of data each time it calls it. So you can say, oh, run this test with this value and that value, or the next time run it with this other value or that other value. Two things I see. One is that somebody will write a test method and then define all of the different behaviors in the data provider. And what that means then is that you've tested the implementation detail and you're still somehow trying to define the behavior, but you're putting it in some other place, which it's messy, just don't do it. And the other thing that I've seen is people using data providers to switch dependencies that are being used. So trying to be too clever and running the same test logic using mocked dependencies and also stuff it gets from the container. And that was, when I first came across that, I was kind of shocked that somebody would think that was a good idea. And testing far away from behavioral boundaries. Who has often thought, if you're writing, say, if you're writing a class, I'm going to try and be quick, right? So if we've got the product and we've got some dependence in the product that there's, I'm writing the test afterwards here, so ignore me doing that. Valid price, right? So let's say, for example, we had the method is valid price, right? So we've got a method called isValidPrice. And this is going to just return, so if the price is greater than or equal to 10 and price is less than or equal to 100. How would we test this? I mean, obviously I'd write the test first, but how would we test that? What values, somebody shout out what values you'd put into a test this method. Perfect answer. Absolutely perfect answer. Yes, that is where the behavior changes. Those are the interesting cases. You see people, when they're first trying out testing, they do things like, well, I know I need a number between 10. I know that, like anything less than 10 is invalid. So valid. Anything less than that is invalid. So 9 equals invalid. It does say invalid, but it's got a few extra letters in it as well. And so a lot of people go, well, okay, well, I'm also going to test -1 and, minus 5,000 or something and, maybe 8, but not 9. The interesting cases are where the behavior changes. So make sure you test those. There's no need to test any other value because if it's less than 10, it's invalid, right? Whatever anyone puts in there. And if somebody puts some sort of string in there, well, then you've got PHP's or your type system, your language's type system to guard against that. If you're not using a language with a type system, then I don't know what you're going to do. Maybe add some extra tests in. Okay, so remember, if there's some key takeaways from today, we add a new test when there is a new behavior. Integration tests should not test the same logic as unit tests. Integration tests are purely about do these components talk to each other? These components I've already unit tested, do they talk to each other? If you decouple your business logic from, who writes all their business logic in the controllers? Does anyone do that? Good. Okay, I didn't see any hands there. If you put all your logic in the controller, you are already making it harder for yourself because you are forced to go up to the integration level for your business logic. And TDD and BDD, who knows what BDD is? Yeah, okay, behavioral driven design. It's where you express the language of the behaviors that you expect. TDD done properly is indistinguishable from BDD. It's just different tools. And these are kind of just general points to remember about testing. Organize your tests by feature, I guess, is more TDD. If I were going to work on something else, say like a product suggestion feature, I would create, I would create here, product suggestion, a set of tests around that, and I would put my unit tests and my integration tests in there. Because then if something breaks, I know where to look. And I know exactly what's going to be broken for the user, if so. And if it came that the product class could be used across both, then I might extract that and put its own tests somewhere else as well. But that is how I would approach that. Test behavioral boundaries, of course. Don't abuse data providers, don't try to be too clever, and test things together which make sense to be tested together. Okay, Oh, you can't see that. I can see that perfectly on my screen. Ah, there we go. It took a while. This video, Ian Cooper, why did TDD go all wrong? Go ahead and watch that. That's a fantastic video. And it basically says, well, the book is so simple and the concepts are so simple. Why did we overcomplicate it? So I would definitely recommend watching that as well. That QR code, scan it. The link's to my Twitter. You can follow me or not. It's your choice.